Here's problem 3725. A soap bubble, index of refraction 1.35, is floating in air. If the thickness of the bubble wall is 115 nanometers, what is the wavelength of the light most strongly reflected? So let's take a look at our bubble. Index 1.35, and outside we have air on either side. And so light coming in is going to go from a lower index to a higher index, so the reflected light is going to have a phase reversal. Then we have refracted light towards the normal, and that will internally reflect off the other interface, but there will be no phase reversal for that because we're going from a higher index to a lower index. So we're going to end up with one phase reversal in this situation. Hence, the light would have destructive interference if that was the only thing going on, but we want constructive interference, so we want the thickness of the bubble to help us with a path length that will give us another half cycle of phase difference. So we want that twice that thickness is going to equal n plus 1/2 times the wavelength within the bubble. This wavelength within the bubble is equal to the wavelength in the air divided by the index of refraction of the bubble. So we have 2nt is equal to m plus 1/2 times the wavelength of the light. The wavelength of the light then would be equal to 2nt divided by m plus 1/2. Let's assume we're at minimum thickness, so m is equal to 0, and we have 2 times n, 1.35, times the thickness, 115 nanometers, divided by 1/2. So what is all that? 2 times 1.35 times 115 divided by 1/2. That gives me 621 nanometers. So the light that is most strongly reflected from this bubble, giving us constructive interference because we have half a phase reversal and then another half cycle due to path length within the bubble, is 621 nanometers. Answer.